Hello Geometry, welcome to 11.3 Areas of Polygons. This is going to start off kind of simple and get into something a little more complicated when we get to regular polygons. So let's start off with our simple area of a rhombus or a kite. So hopefully you remember a rhombus is a parallelogram so that the diagonals are bisected. They are not congruent, but they are bisected and they are perpendicular. So you have four congruent right triangles. In the kite, only this vertical diagonal is bisected, but these are still perpendicular and our formula will still work. The derivation would be a little bit longer, but I do want you to see how this works. So the area, just going to give it to you first, is 1/2 diagonal 1 times diagonal 2. That works for both rhombi and kites. But let's take a look at a rhombus and see why this formula would work. So you have all four sides are congruent, the diagonals are perpendicular, the diagonals are bisected. So what happens is we have four triangles. Now if I just focus on one of the triangles, I'm going to focus on this triangle. And so we can notice that this is the base, this is your height. So the area of one triangle is 1/2 the base. But what is the base? The base is half of a diagonal. I'm going to call it diagonal 1. What is my height? My height is half of the other diagonal. So when I simplify this, this 4 will cancel with both of those 1/2s, and voila, we are left with 1/2 diagonal 1 times diagonal 2. And so that is a nice simple derivation of that formula. So let's do a couple examples. I have here a rhombus because all four sides are congruent, and I know the diagonal 1 and diagonal 2, so all you have to do is 1/2 24 times 10. Now always make sure if you're only given like half a diagonal, you're going to have to double it. Okay, so make sure you've got the whole diagonal. This is diagonal 1, this would be diagonal 2, doesn't really matter which one you call 1 and 2. So I have half of 24 is 12, and 12 times 10 is 120. And because we are talking millimeters and area, it's going to be millimeters squared. Okay, over here we have a kite, but the formula works the same. It'll be 1/2 5 times 11, so that would be 55 halves feet squared. And as far as I'm concerned, you can leave your answer like that. Some of you like to have proper fractions or decimals, but then I'd have to touch a calculator, and that takes more time. All right, so that's the area of a rhombus or a kite. Now, what if you had more sides? So first thing, we're going to do this in little pieces. We are going to concentrate on if you were to inscribe a regular polygon. Remember, regular means all the sides and angles are congruent. They're all going to be the same. That makes it regular. So if I can inscribe any regular polygon into a circle. So you can see down here we have a pentagon. And the pentagon is inscribed in a circle. And you have something called the, now I've always been saying this wrong, but I really like how I say it. It's the apothegm. And you have to say it with a British accent, but it's really, I think it's actually not how you say it. Apothegm, I think, is how it's really said, but that's just so American sounding. So the apothegm is from the center. So if you have it inscribed in the circle, it's the center of your circle, the center of your polygon, and you drop a perpendicular to the side. So it's not the radius, it drops perpendicularly to the side. That is what we call the apothegm. And the apothegm is basically the height of a triangle one of the triangles, so every single triangle in that polygon has an apothem, but they would all be identical. All right, then we know that all our side lengths will be the same, and we refer to that with S. So S equals the side length. We're going to identify all our variables. Then N is going to represent the number of sides. So in this one, in the pentagon, we have 5 sides. Sometimes you will also see P, which will represent perimeter. And remember, perimeter is the length of a side times the number of sides. So these are all just sort of little things that we want to come up with. So we also want to talk about, since that was the heading here and I went off on a different topic, the angle measures in the regular polygon. All right, so we know that a circle is 360. That means that around the center here in the middle, I know that all these angles should add up to 360. You've also, I don't know if you remember, but you also had something that talked about the sum of the angles in a polygon. This is a little good review. Remember that the sum of the angles in a regular polygon had as a formula n minus 2 times 180. And if we wanted to find just one of the angles, we would divide by n. So that would equal just one angle. All right, so I've got a pentagon, and I want to find all my different angle measures. So let's draw this out. I know that the sum of the angles will be 3 times 180, which equals 540. And if I then divide that by the number of angles by 5, that will give me, each angle is 108. All right, so this angle would be 108. So because the radius coming out would divide that in half, each one of these is going to be 54. 54 as we go around. All right, because the whole angle has to add up to 108. Now sometimes it's important to know about the central angle. So as you saw above, I drew a circle there, and that circle is 360. 360 divided by 5 is 72. So each central angle is 72 degrees, but if I drop an apothem, which again drops perpendicularly, 72 gets cut in half, so this would be 36 and 36. So that's how I would go about finding those angle measures. That will be important because sometimes you're going to have to use trigonometry in order to find the length of a side or an apothem. And again, to use trigonometry, you need to know an angle. Now this next shape is something. Let me see. Oh, 11 sides. Well, isn't that fun? Okay, so if I have 11 sides, I'm going to need a calculator. Let's find some of these angle measures. So first off, 11 sides means that the sum of the angles will be 9 times 180. And so we have 9 times 180, which is 1620. And then we're going to divide that by 11. Ooh, yuck. All right, so each angle, this is not a pretty one to do. Is that really 1, 2, 3, 4, 5, 6, 7, 8, 9? No, it's 10. Sorry, I always, because they didn't put I in there. Well, that was cheating. Okay, so it's going to be 8. Thank goodness, because otherwise it was going to be a really ugly decimal. All right, so this is going to be 10 sides. So this is a decagon. So I'm going to go 8 times 180. Huh, much better. Which is 1440, but then we divide that by 10, so evenly, because everyone gets the same. So each angle will be, this will be 144 degrees. Each angle will be 144. So that equals one angle. Now when you draw the triangle, it cuts that 144 in half. So this now is going to be 72. This is 90. And the full central angle is 360 divided by 10, which is 36. So if I did a full central angle, this would be 36. But when you drop the apothem, each little angle in the half triangle will be 18. All right. Okay. Hopefully this is okay as we're going through this. This next one, 1, 2, 3, 4, 5, 6, is a hexagon. So in a hexagon, hexagons are very special because 4 times 180, because you have 6 sides, 6 minus 2 is 4. 4 times 180 is going to be 720 divided by 6 means that each angle is 120 degrees. But when you draw these radii, it breaks this into 60 and 60. So what happens is every hexagon, only a hexagon, has 6 equilateral triangles. So all the triangles are going to be 60, 60, 60. So then, of course, when you drop that apothem, realize that's going to create a 30, 60, 90 triangle, and everything we did in chapter something or other a while ago is going to come back. All right? Okay, so what we looked at is how you can find the angle measures in a regular polygon, but what we're really after is the area of a regular polygon. So hopefully you notice we can always make triangles out of our polygon. Remember, A is going to represent your apothem, your apothem. S is going to represent the length of a side. N will represent the number of sides. P is going to represent S times N, which is the perimeter. And then let's look at this. All right, so I have here, if this is a pentagon, I'm going to have 5 sides, which means I'm going to have 5 triangles. So my area is going to be 1/2 base times height, which would be S times A. I'm going to rearrange this in a second. And then how many triangles? Well, that depends on the number of sides you have. So the way we tend to write this is 1/2 ASN. I call it half-assen, but you can call it whatever you want. All right, so 1/2 ASN. 1/2 the apothem times the length of a side times the number of sides. And since S times N also represents your perimeter, some people like to simplify this down to 1/2 AP. So half an AP. All right, this is basically the formula. Seems so simple, but it's finding the parts that can be a real booger. All right, so let's do this. We're going to start off here with a lovely hexagon. Hexagons, there's some shortcuts we're going to do later on to show you for a hexagon. But let's start off here. So it tells me the whole diameter of the circle is 32, which means my radius is going to be 16. And remember that within, so I'm going to draw out half of this triangle, this base angle, remember, was 60. So this angle's up here is 30 because you have 6 equilateral triangles in this hexagon. And so we know that the radius is 16. That means that half the side here, well, we know the whole side is 16 because it's equilateral. But that was 8, which means your apothem is 8 rad 3. So you have your 1 rad 3 2 ratio that you still have to deal with. So this here is your apothem. So the area of this is 1/2. My apothem is 8 rad 3. The length of a side is 16, and the number of sides is 6. And when you multiply all that lovely stuff together, So 4 times 6 is 24. 24 times 16, it's going to give me 384 rad 3. And that would be the area. So anytime you're doing a hexagon, it's basically going to be 6 equilateral triangles. So if you notice, there's the 6, and then to find the triangle, it's 1/2 base times the height. All right, now we have a triangle. And remember, so this triangle, if I could inscribe a circle around it, and the radius is 10. So this is, again, it's an equilateral triangle, so these angles are 60, and I'm going to drop my apothem to one side. So if I kind of did this all the way around, we know each one of these is going to be 120, which means this is 60 and 60, and now my base angles, which were 60, get broken up into 30, 60, 90 triangles. So let's kind of draw this out. This was my apothem, and my radius is 10, and we know down here is 30, up here is 60. So opposite is, so that means the apothem now is going to be half of the radius, and that makes half of this side is going to be 5 rad 3. So the whole side, which is S, is going to be 10 rad 3. I told you guys these special triangles are still going to be with us. All right, so let's put this all together. Area is going to equal 1/2. The apothem is going to be 5. The length of the whole side, not just half a side, because what I pulled out was just this piece. The whole side is going to be 10 rad 3. And how many sides do I have? I have 3 because it's a triangle. So I have 50, 150, half of 150 is going to be 75 rad 3. And that's going to be my area. Okay. Now a square, and this is kind of silly, I don't know. I'm a little bit miffed at, I personally, remember a square is also a rhombus. So we could go through and figure everything out, and this would be 45, 45 at this point, but I'm going to also show you a shortcut, because if this is a rhombus, and remember, in a square, your diagonals are congruent. So we'll figure this one out 2 ways. If I treat it like a rhombus, each diagonal is a length of 12. So this would be 1/2 12 times 12, which half of 144 is 72. All right, so that would be the area of my square if I treated it like a rhombus, which is really the easiest way to do it. All right, let's do it the harder way because we're gluttons for punishment. So if this is 6, now remember that's on the rad 2 side. So I would have to go 6 equals x rad 2. So then 6 divided by rad 2 equals x. So x, when you rationalize your denominator, will be 3 rad 2. So each of these is 3 rad 2, 3 rad 2. That means the whole side is double that, which is 6 rad 2. Okay, now let's do our area equals 1/2. The apothem is 3 rad 2. The length of a side is 6 rad 2, and we have 4 sides. So 6 times 4 is, okay, how do I want to do this? So rad 2 times rad 2 is 2. And that's going to cancel with the 1/2. So then we just have 18 times 4, which guess what, is 72. But that was so much more work. So again, remember, a square is really just a rhombus. But they might ask you for the individual parts, like find the apothem, or, something like that. Okay, now, those were kind of friendly. I didn't have to touch a calculator. Now we get to the pentagon, which we found the angles in the previous page. So a pentagon here has a radius of 4, and remember that each of these angles down here ended up being 72 because we were cutting 144 in half, And 360 divided by 5 was 72, so up here it was 36. And again, so we're gonna look at this triangle right here. And I'm gonna pull it apart, pull it down here so we can write a little more in it. So this angle's 72, this angle's 36, my radius is 4, this is my apothem, and this is half of the side, right? Because we're gonna eventually need to know the whole side. So we wanna find the length of the apothem and the side of the pentagon. So what I'm gonna do is on the inside here, I'm gonna use the 72 as my reference angle. That makes this the opposite, this the adjacent, and this the hypotenuse. And yes, we are gonna have to use trig. So to find the apothem, to find my apothem, I'm going to have to do opposite and hypotenuse. So that would be the sine of 72 degrees is the apothem over the hypotenuse, and then we can multiply both sides by 4. And we go to our handy dandy calculadora. 4 sine 72 is about 3.8. So that will be my apothem, 3.8. Now we want to find the adjacent, which is a cosine. So I know that the cosine of 72, so this is going to be, again, this is finding half of a side, is going to be, I guess I'll call it half of my side divided by 4, and again, we want to multiply both sides by 4. So 4 cosine 72 is 1.2, I'm going to put in an extra decimal, because to find the actual side, we need to double that. And, well, I will round off nice. I'm going to just round it off to what? To 2.5. All right, so my side is going to be 2.5. That's the whole side. That's a lot of work. You're right. But that's what you're going to have to go through if it's a pentagon or a heptagon or something that doesn't have a nice even number. So the area of this puppy is 1/2 the apothem, which is 3.8, times the length of the whole side, times the number of sides. And we just plug that into our calculadora. So 0.5 times 3.8 times 2.5 times the 5 triangles gives me 14.4. Oh, and they actually gave us units this time, inches squared. Okay. That's interesting. I wonder if I did, I'm looking at my answer from last year. It all depends on how you round things off. But I think, I think I used different numbers too. Okay, we're good. All right, well, hopefully that makes sense. We're going to spend some more time with area of a regular polygon in an investigation where I will show you some shortcuts as well.